welcome back to Pass the Torque. I'm your host, Katie Cadre. So far this season, we've heard about on-orbit servicing, assembly, and manufacturing, or OSAM technologies. Today, we're going to hear about robotics from robotics engineer Zakiya Tomlinson. Don't forget, you can drop any questions you have for Zakiya in the comments below for a chance to have them answered later this week. Let's go ahead and get started with question 1. What does a day in the life of a robotics engineer look like?
One of my favorite things about my job is that no day is the same. I might spend one day using our robots in our lab to test out a new tool or task. I could spend another day in meetings going over plans for how we're going to run our mission, or spend the time writing reports about how our last test went. I could spend a day training other engineers on how to safely operate the robots, or working with our interns to help them with their tasks. So I really enjoy the variety that comes from the job. So I really enjoy actually getting to do testing with the robots. I really enjoy the experimentation, trying to figure out how something's supposed to work, overcoming problems is really the most fun part of the job.
Can you tell us about your background?
So I actually started my engineering education while I was still in high school. I attended a magnet program in Howard County, Maryland. After that, I got my bachelor's degree in aerospace engineering from the University of Maryland, College Park, and a master's in aeronautics and astronautics from MIT. I actually haven't worked anywhere other than at NASA. I was an intern when I was still in college at Kennedy Space Center. I worked in testing experiment racks that were going to the International Space Station. And after I finished my master's degree, I spent 2 years at Johnson Space Center in Houston as a robotic instructor for the International Space Station program. I really enjoyed the experience of being able to teach classes and work with the astronaut candidates and the crew of the second to last shuttle mission, STS-134. After I left Texas, I moved up to Maryland, and I've been working at Goddard Space Flight Center for the last 9 years.
How are robotics applied differently on Earth and in space? How can robotics enable further space exploration?
A lot of robotic systems that are on Earth are used for tasks that are either requiring a lot of repetitive actions or a high degree of precision, things like putting together cars or other machinery. Both on the ground, though, and in space, robots can be used in environments that it's too difficult or too dangerous for humans to go. So on the ground, that can be things like exploring underground, or things where there are maybe things like explosives. In space, robots don't get tired, they don't need food, so they can be able to move large objects, they can stay out and keep working beyond when humans would need to go inside to get rest or to get more oxygen for their spacesuits and things like that. So they are able to provide support for a lot of tasks in space that alongside people, or doing tasks instead of people. One of the other things that in space, robots are able to go to places that we can't send humans safely yet, other planets or other bodies in our solar system. So that allows us to gain more knowledge about what else is going on in our solar system even earlier than when we'd be able to send people there.
What are some challenges of using robots in space? What can robots do in space that humans can't, and vice versa?
There are a lot of different things that robots can do in space, from constructing large structures down to picking up tools or setting up an environment so that an astronaut could work with it later. The robots are really great for the larger tasks, especially. There's things that are too big for humans to lift. One of the challenges, though, when you get down to some of the smaller tasks, is that it's much more difficult for robots to sense their environment like a human does. The human hand is a really amazing instrument, and so once you're trying to get a robot to emulate that, it's a very difficult thing to do. You need sensors to be able to determine how hard are you pushing on something. You don't want to crush it by accident. You need to be going more slowly so that you can stop when you start seeing cues that the robot is doing something that you may not want it to do. So it can often take more time for a robot to do a task than a human could, but at the same time, they could also be performing those tasks, let's say while the crew is asleep, and that's going to help your schedule because you'll be further ahead in the morning than if you were waiting for the crew.
Can you tell us about how robotics will be used in the OSAM-1 mission?
Robots during the OSAM-1 mission will be used to service a science satellite that's already in space, as well as demonstrate manufacturing and assembly capabilities in space. Right now, if a satellite is running out of fuel towards the end of its mission, a lot of times the instruments are still functioning, and so it could still continue to give us really great scientific discoveries if it had more fuel. And so that's what our point of the mission is, to allow this satellite to continue operating for a longer period of time, based on what a robot can do to help out with refueling. Once we've done that, we'll also be demonstrating for the future, and hoping to expand our capabilities of what robots can do for assembly. Right now, we're limited in kind of how big structures in space can be by what can fit onto a rocket. And so if we can use robots to assemble pieces together once we get into space, that'll allow us to build new structures for new purposes and improve the missions that we can do in the future. The humans on the ground will be able to watch what's happening on the spacecraft through cameras and then send commands to the robots to be able to grab onto the science satellite, in the first place, bring the two satellites together, and then get access to the fuel valves using various different tools that we'll need to cut through the outer protective blanketing, remove caps that are on the spacecraft so that you can actually get to the fuel valves, and then you'll pump fuel into the spacecraft and cover everything up once you're done so that the spacecraft can then continue on its way and continue its mission. The main reason we don't want to use the joysticks in space is because it's harder. You can't verify what your commands are. It's kind of just an instant, you've sent an input and the robot would respond to that, versus the commands that you can type into the screen. Someone else can lay eyes on that and verify that that's actually what you want to send to the spacecraft before the robot acts on that input. There's a several second delay between when we would send the command on the ground and when the robot would respond, based on as kind of that signal bouncing through different ground stations and then up to satellites to space. So that also makes it less desirable that you would be inputting things by joysticks, because you want to be able to verify everything, because you won't see the robot start moving instantaneously because of the delay. So if it was doing a wrong command, it would already be moving by the time you knew that, to then be able to stop it.
How else is NASA using robots?
So a couple examples of how else NASA uses robots are the International Space Station and Mars rovers. The space station actually could not have been constructed if it weren't for the robotic arm that it has on board that was used to lift and install many of the modules that are on the station. And right now, the arms still get used for being able to do maintenance tasks, repairs, docking cargo spacecraft that come up, and also conducting experiments on the station. On the Mars rovers, they have robotic arms that are used to collect and analyze samples as they're traveling, so you can learn more about the rocks, the dirt, and the area that they're moving through. I guess the largest difference between different robot systems, whether it's for OSAM or on the space station or on Mars, is the sizes between them. But different robots can have different numbers or different types of joints, and that will affect their ability for how they move. Especially for, let's say, the Mars rovers and a lot of smaller arms, they'll have joints so that they can move very similarly to a human arm, with a shoulder, elbow, and wrist. One of the unique things with the arm on the International Space Station is that its wrist can become its shoulder and vice versa. So either end of the robot can attach onto a structure and become the shoulder, and the other end can be out grabbing other objects like the hand or the wrist of the robot. And so that allows it to travel around the station and work in different areas without the robot having to be even larger than it already is.
What are you most looking forward to at NASA?
So every year, both during the summer and the school year, we have several interns that work with our group. Some of them are in high school, some of them are in college, some are focused on mechanical design, and some working on software. But this summer is my 5th year of working with and coordinating our interns. And every year I look forward to the new students that come in and, the things that they're going to discover both through their work and about themselves. It's really, really, really amazing when they find, new interest that they didn't know that they had, or if someone confirms the fact that the career they always thought they wanted really is what they want to do with their lives. So I always look forward to working with them every year and finding new students to work with us in the future.
What is your favorite memory from your time as a robotics engineer?
My favorite memory from my time here as a robotics engineer was working on a test campaign at a facility up in Canada. The robotic arm that's used on the International Space Station was designed by the Canadians, and they have a facility there that has almost the same hardware and software as what's on the station. And so we were using this to be able to test out an experiment that we were going to run on the space station. And it was a lot of work leading up to that to get ready and a lot of long hours when we were there, but it was a fantastic opportunity to learn from other people doing similar things that we're doing, share our techniques and our knowledge that we've gained over time together. It was just a really great learning opportunity to help us hopefully make our own mission better and from the knowledge that we got.
How did you first become interested in robotics?
So during my senior year of high school, my teacher entered my class into a robotics competition called Bot Ball. It's a lot like First Robotics. That was my first exposure really to robotics or to programming, and I really enjoyed both. I didn't think of it at the time as a career that I might get into, but kind of that opportunity led to other opportunities, which led to other opportunities along the way. So I'm really glad that I gave it a chance as something new when I was in high school, because it's shaped my life ever since.
What advice do you have for people who want to get involved in robotics?
There are a lot of different aspects to robotics, whether you like programming or you like design, you like to do testing. So I guess my best advice, if they think this is something that you would be interested in, is to find a way through clubs or your classes in school or research opportunities to get involved and try a bunch of different things and see what you really like, so you can hopefully find some aspect that you really love and continue working in that.
What do you like to do for fun?
My greatest love, other than space, is traveling. When I was in college, I was lucky enough to spend a summer doing study abroad in Europe and living on a ship. That really started a deep love of seeing new places and getting to experience and learn about new cultures. I've gone to almost 30 states and 35 countries around the world so far, and hopefully someday I'll be able to say that I've been to all 7 continents. I equally love going to places that are beautiful just for nature, like mountains in Alaska or coral reefs, scuba diving in the Caribbean, as well as going to big cities and famous landmarks like New Orleans or Paris. Really, I love everything about traveling, from all the time you spend planning and anticipating, even the time that you have to spend packing, and of course, actually enjoying the adventure while you're there.
Thanks so much, Zakiya. And thank you for tuning in to another episode of Pass the Torque. Don't forget, if you have any questions for Zakiya, you can drop them in the comments below for a chance to have them answered later this week. Be sure to check back here next week for another brand new episode of Pass the Torque. See you then.
All right, for a little bit of show and tell, one of my other interests is sports. Football, hockey, and racing are my favorites. And I collect different items from the different teams and races that I've been able to go see in person. So some of my favorites here relate to the championship that my local teams have won. So the football in the back is from the Ravens. I have 2 hockey pucks for the Capitals, including for their win in the Stanley Cup. And I also have a ball for the Nationals. And I also have newspaper covers from when each of them won, which was really exciting and a lot of fun to watch those games. For racing, I started collecting cars for the different drivers that I follow. I really am fascinated by the technology that goes into racing. It kind of like this technology that goes into spaceflight. But it's a lot of fun to learn about, and every year I look forward to May to be able to go to Indianapolis and see the cars at the Indianapolis Motor Speedway. There's really nothing like seeing a car go 230 miles an hour.